So today, the VMware NSX technical deep dive that we're going to cover is actually going to be focusing more on the NSX vSphere portion. So just to let you know, to kind of set the stage here. And, well, maybe a brief introduction. My name is Ben Bassler. I'm part of the product management team responsible for NSX. I specifically have an interest in the underlying infrastructure, like the overlay, the data plane, control plane, and management plane aspects, layer 2, layer 3, these types of aspects. And with me, it's a pleasure to have also Roberto Mari, one of the first VCDXs that there are for network virtualization. And so thanks very much for joining us, and we're going to get started. Roberto.
Thanks, Ben. So thanks for the introduction. Just a quick introduction on my side as well. I'm Roberto Mari. I'm Manager of Technical Marketing at VMware. As part of the VMware team, I cover specifically solutions that we are building for customers, such as reference architectures, or software-defined data center solutions. So let's start. As Ben pointed out, we have a lot of material to cover. And so we'll try, of course, to cover this as much as we can. The basically objectives for this session is to provide you with a deep understanding of the NSX components. As we only have 1 hour, we are going to focus more on the architectures and the specific NSX components. And we are going to also touch base on some of the most relevant features, for example, like logical switching and routing. Throughout the presentation, you will see some small bookmark on top of the slide. That means that in that case, we give you a pointer on where to find additional documentation for that specific topic. So we also want to explain how NSX provides as a platform the networking function and services. So as you know, NSX is the VMware networking virtualization product. So we provide network virtualization feature and security features. We are going to cover that. We're going to analyze some of the key workflow in NSX, meaning what are the basic configuration workflow for installing the system, for configuring the environment, for configuring a multi-tier applications. And of course, we're going to provide you with plenty of pointers throughout the presentation on how you can find the additional documentation on our website or through the remaining sessions. So very quick, super quick slide here. I mean, you should be familiar by now with what is NSX. And if you have attended our NSX intro, we did explain some of that. But you basically have all the VMware solution around compute virtualization, around hybrid cloud, and software-defined data center. If you heard today at the keynote, network virtualization is one of the fundamental pillars for SDDC, or software-defined data center. Along with storage, along with compute, we basically provide network virtualization. That's where NSX sits. That's where NSX finds a place. So what is NSX? This is a very simple sentence, but I would say summarized very well. It's a faithful reproduction of networking and security services in software. And what are these network and security services? Well, basically, we provide in logical space switching, we provide routing functionality, firewalling, load balancing, VPN, layer 2 and layer 3 VPN. And on top of the on top of this logical construct and logical networking and security service, we also provide a way of connecting the physical environment that you have in your data center to the virtual environment through these logical networks. So let's see what we can do with NSX. So at the end, the main scope of NSX network virtualization is to help you to build like this application, multi-tier application topologies. That's the final goal, right? That's what you want to achieve from a business standpoint. And so effectively what you do with NSX, you can, if you have a set of workloads, you can provide the networking function, like for example, logical switching. So these workloads can communicate at layer 2. You can have multiple tiers of this layer 2. And these layer 2 tiers can be connected together via logical router, right? So you have these very complex topologies. And along with basic switching and routing, we also provide firewalling capabilities. If you heard the keynote today, this is one of the main and the most common use cases we have from customers. We call it microsegmentation. Firewall applied at the VNIC level for every virtual machine in the environment. Plus, of course, we have additional services. We are going to cover load balancing, some of the NAT functionality, and DHCP relay. And when we talk about virtualization, we don't only focus on the virtual environment, but also how you connect that virtual environment into a physical environment. So we have a way for connecting that. At layer 3, we use the edge gateway. We are going to cover some of that. And we use routing protocols to pair with the physical fabric. And also, we have a bridging functionality. So you can bridge a physical workload at layer 2 with a logical workload. So you can send that logical layer 2 from virtual into physical. And all of that can be done with the NSX functionality, the NSX component, but we also realize that our customer need basically additional functionality that maybe we don't provide as part of the NSX. For that reason, we also integrate with our technology partners to provide some of the service insertion capability for advanced functionality, such, for example, advanced firewalls or advanced load balancing. I would say some of the logical construct that we have and some of the features provide for 80% of the use cases, but there is the 20%, for example, if I want to do advanced state for firewall and I want to use a Palo Alto network, we basically provide for that service insertion and functionality. Everything is controlled by the NSX manager and the NSX controller. Everything is orchestrated. So when we talk about logical networks, we don't talk just about the click-click experience, but we talk about how I can consume this in a very rapid fashion. And so it is important to understand that the orchestration that NSX provides can also be basically exported to a cloud management platform that can consume that infrastructure. So let's talk about the architecture and component first, and let's step through the remaining part of the presentation, covering switching, routing, firewall services, and then give you the pointer for the rest of the documentation. From an architecture and component standpoint, you, of course, in a data center, you have a physical fabric. So there is no difference with NSX. You need a physical fabric for IP connectivity, right? The thing is that basically NSX does not pose any restriction on that physical fabric. You can use the vendor of your choice. You can use the specific design that you want. There is no specific restriction that NSX will pose there. And when we step into more of the virtual and logical components, NSX provides a data plane function. This data plane function is distributed at the host level, at the hypervisor level. So as Ben pointed out, here we're focusing on ESXi and vSphere. And here we talk about what are the components of the ESXi platform that provides for that data plane function. Along with the hypervisor, we also have virtual appliances called the NSX edges that provide perimeter services, right? So we are going to cover a bit this more in detail, but just suffice to say that this is the data plane for NSX, fully scale out, fully distributed. The NSX controller, this is the control plane. This is basically where you manage these logical networks. You create them, you configure them, you can monitor the environment, right? And so the controller itself takes care of programming the data path. And northbound, it connects with an NSX manager that offers the single pane of glass for managing the entire NSX environment, right? So the NSX manager itself basically offers a RESTful API layer to a cloud management platform. And that cloud management platform could be a vCloud Automation Center if you're looking at a fully integrated solution that VMware provides, or could be a third-party cloud management platform such as a custom portal or, for example, OpenStack. So what you see here is basically all the items in color are part of the NSX environment, and all the items that are grayed out are kind of complementary items into the NSX architecture. So let's talk about the data plane components. Talking about the data plane and talking about the overlay and these logical networks, there are two entry points in these logical networks. The first entry point is the host. The host itself, the ESXi host, offers connectivity into the virtual machines, into the virtual endpoints. And on the other side, you have the edge cluster, or the edge service gateway cluster, which provides the entry point from physical into virtual, right? Each of these, I would say, entry points into the logical environment can be scaled out. So you can scale out hypervisor to build an hypervisor cluster. And basically, as the data plane is fully distributed, the more hypervisor you add in the environment, the more you augment the capacity, forwarding capacity of the system. So east to west traffic, for east to west traffic, all the data plane function will be done at the hypervisor level. For south to north traffic instead, you basically will use this edge service gateway to get in and out from the logical space. And these edge service gateways or digit clusters can be scaled out as well. So you can have multiple of them as you scale the number of tenants, as you scale the capacity. So looking at what we provide inside a single host. In a single host, we have multiple kernel modules. And those kernel modules provide capabilities such as VXLAN forwarding, distributed logical router, and distributed firewall. All these single components run in the ESXi kernel space, so we can provide for the best performance as we optimize the data path in the kernel space. And then we use a logical construct, which is the virtual distributed switch in ESXi. The virtual distributed switch is the native virtual switch of ESXi and allows for distribution of these configurations, port groups, in this case, for example, firewall rules or routing configuration on each of the hosts. So VDS used for distributing the configuration and the kernel modules into the ESXi for the data path forwarding. The edge service gateway, it's basically the appliance that provides for that south to north connectivity. It's a VM 4-factor appliance, right? And it's highly available. So you can deploy an edge service gateway in a redundant fashion, active standby. It provides, it's a multifunctional software appliance. It provides for multiple functionality. One of the functionalities is the layer 3 functionality. And from a layer 3 standpoint, it provides features such as the dynamic routing protocols, OSPF, BGP, ISIS. Those routing protocols allow the logical networks to be connected with the physical network. So you can route the packets from your tenant logical environment into the physical space, into the physical fabric. And those edge service gateway also provide layer 3 to layer 7 basically functionality. So things like NAT, that is very important if you have a multi-tenant environment, or DHCP relay, load balancing, VPN, and firewalls. Let's talk about the control plane component. The NSX controller is the fundamental brain of the system. As we said before, the controllers allows you to program all the data plane of the environment. It's a virtual form factor appliance, also in this case. The spec of that VM is defined at installation. It cannot be changed. It's a 4 virtual CPU and 4 gig of RAM. Basically takes care of programming the host and takes care of programming each of these VXLAN, distributed logical routers, modules. And it can scale out. The technology itself of the controller is a cluster technology. Today, we support up to 3 controllers in the cluster, and each of the controller can take a piece of load in the configuration of the logical environment. There is no limit, though, to the technology, so maybe in future, we'll be able to add more controller if needed, but as of today, basically, we can meet the vSphere typical scale requirement just with the existing configuration. In terms of high availability, it's completely highly available. So if you lose one of the controller in the cluster, you don't lose the functionality of the control plane, right? So, which is very important, right? As the state is completely replicated across the controllers, each controller failure can be recovered and can be basically taken care by the remaining controllers in the cluster. One other important capability here is that with VXLAN implementation, we don't require in NSX any more multicast. And this is thanks to the NSX controller architecture, as the NSX controller orchestrates the VXLAN configuration. So prior to NSX, multi-destination traffic required for multicast services from the physical fabric. As of NSX, basically the host itself and the controller can take care of programming properly the data path and taking care of replicating this multi-destination traffic in the environment. Another capability is ARP suppression. Each of the controller has a directory service, so he knows very well where each virtual machine sits, what is the IP address of that virtual machine, and what is the MAC address. So if there is an ARP request generated in the layer 2 environment, the controller itself can respond on behalf of the destination and can suppress that ARP. So there is no more requirement to propagate ARP broadcast traffic into a layer 2 logical network. Another important piece here is the control plane isolation, which basically tells you that the controller itself, it's not in the data path of traffic. So if you have packet processing, that packet processing only happens at the host level. The controller will never see a packet. If there is a controller failure, the data path of the traffic is not impacted. So you can very well have a controller failure or multiple controller failure, and your traffic in the logical network will continue to forward. Existing logical network will continue to be functional. In order to get best resiliency, what we recommend is to deploy these controller appliances into a vSphere cluster. And of course, in a vSphere cluster, you can enable features such as high availability or DRS. You can set anti-affinity rules to make sure that these controller appliances land on different hosts in the cluster. So if you lose a single host, you don't have a single point of failure for all the controllers. And as we said, the controller takes care of programming the data path. So if we look at the host as a specific modules running on a host, we'll see that we have a kernel module with all the different data path modules, in this case VXLAN and distributed logical router. And then we have what we call a user agent that communicates with the controller. The controller instructs the programming of the data path through the user agent running in user space that programs the data path into the kernel. And now, thanks to that programming, a specific VM can communicate into the overlay using a specific VXLAN or a logical switch or a logical router. Let's talk about the management plane. NSX Manager is the center of the management plane and takes care of consuming, programming, configuring all the logical networks. It's a full functional, NSX Manager has a full functional UI, so you could go in NSX Manager and take care of the entire operation of NSX, but of course, it is important to note that NSX Manager doesn't function by himself. It does use some of the constructs, for example, that are available in vCenter. Things like the security tag, the virtual machine names, things like, for example, the VDS construct. So there is a one-to-one relation between an NSX Manager and a specific vCenter in your environment. And northbound, in order to consume now these logical networks in a programmatic fashion, it will basically offer a RESTful API infrastructure for the cloud management, for example, VCAC, to instantiate blueprints, to consume this logical network, to create those logical network on demand. NSX Manager, also in this case, is a virtual appliance. As you can see, everything here from a management standpoint is completely virtual. And it takes care, other than programming this logical network in terms of configuring them and consuming them, the NSX Manager also takes care of the preparation of the system. So when you install NSX in the environment, NSX Manager will push all the right information to each of the hosts, all the different kernel modules, will take care also of preparing the system for NSX, will take care of instantiating the controllers. Another important function of NSX Manager is to provide interoperability or service insertion with third-party management tools. In this case, for example, if we take the example of Palo Alto networks, right? If you want to basically insert the Palo Alto network distributed firewall into NSX, you will register first the panorama management station of Palo Alto through NSX Manager. And then from now on, via NSX Manager, you can decide which traffic you want to redirect to the Palo Alto network appliance. And in the Palo Alto network appliance, you'll be able to configure these policies. So it's a very important rendezvous point also for inserting services and registering third-party applications. Finally, as we said, NSX Manager and vCenter have a one-to-one relation. Important to note is that after you install NSX Manager, you register that with the vCenter appliance. In vCenter, NSX Manager will inject a plugin, and now from there on, basically, you will be able to manage and have the same functionality that you have in NSX Manager inside the vCenter UI. That gives you all the look and feel functionality that you have today in vCenter and vSphere, and you will have a new menu, which is Network and Security, where you have all the networking functions. As you can see here, we show some of the reference sections that will be useful for you to attend or download content. In this case, we have a VCAC and NSX integration deep dive that covers most of the management piece, and in this case, VCAC and NSX integration very much in detail. Let's talk about, now that we have seen all the components, let's talk about some of the interactions between these components. And let's take a specific workflow, which is the preparation installation of the system. When we install the system, the first thing we do is deploy an NSX Manager appliance. Then we register that with vCenter. After we register that with vCenter, now in vCenter we have an NSX full functional UI. From that UI, you can go and create the NSX controllers appliance. So you will instantiate this controller appliance, and now based on the policy that you have allocated in that cluster, associated in that cluster, such as vSphere HA or DRS, these controllers VM will be distributed in the system. Fourth step is basically preparing the environment. And what you can do is that, in this case, in the installation tab into the NSX UI, you'll be asked to install NSX and prepare for NSX a specific set of hosts. This could be individual hosts, or of course, you can install and prepare for NSX a set of clusters that you have in your vSphere environment. The installation piece is very easy. You select a cluster, you right-click, install, and that will push all the VIPs, in this case, all the kernel data path modules required for NSX to operate in the system. Then, from now on, you basically go and create networks. And one of the most common things that you will do is to create a logical switch or create an edge gateway service to provide for example, layer 3 routing functionality, or to provide for load balancing or centralized firewalls. So if we look at the deploying and configuration steps, you have two basically buckets. You have a one-time configuration, which is the installation of the appliances, and the preparation of the system that is just one time. You do it only when you prepare the system for NSX. And then you have the creation, the programmatic creation of these logical networks that is more of a recurring configuration on the right of this slide. So let's go and move now into more of the specific feature and function, and let's look at switching here. What are the problems that we are trying to solve with the NSX logical switching? First of all, with virtualized environment, handling a virtualized environment in terms of multi-tenancy and in terms of workload being dispersed inside your data center, the main challenges are that segmenting this virtual application is very hard. You need to provide VLANs, you need to extend VLANs inside this environment, and this brings you some challenges. First, the provisioning of the VLANs, the number of the VLANs that goes with the number of applications, and of course, with that level of skill, you'll also have issues, right? Things like, for example, if you have on this layer 2 domain spanning tree running, you may have issues such as, for example, misconfiguration of spanning tree or failure of spanning tree that can trigger a big mess in your data center. And on top of that, you have also consumption of the physical fabric resources. So the moment you introduce virtualization, you multiply of several, well, one or two order of magnitudes the number of workloads that you have in your environment, right? And so that puts a lot of stress on those tables that these physical switches have: MAC address table, FIB tables, and routing tables. So the solution is to provide an overlay functionality and use the VXLAN overlay to provide that logical switching abstraction. So in this case, We abstract from the physical layer, right? And when you instantiate a new VNI or a VXLAN ID or a logical segment, you are not consuming anymore any resource in the physical fabric. You are not required to instantiate a VLAN. You are basically programmatically at the hypervisor deciding that that specific application or VM needs to be encapsulated in a given tunnel or in a given logical switch and needs to reach a certain set of destinations. That's something that basically it's done at a hypervisor, and so it does not, again, consume any of the existing network environment. So now that we have been talking for a while about overlays, and we've been talking for a while about VXLAN, what does it mean from a data packet processing standpoint? So let's assume that we have two virtual machines sitting on two different hypervisors. This virtual machine needs to communicate with each other. So that virtual machine on the left will try to send a layer 2 frame. Hypervisor will know that that virtual machine is connected, let's say, with logical switch 10, for example. And what it will do, it will encapsulate that layer 2 frame into UDP packet, which is a VXLAN UDP packet, and send that packet across the fabric. As the packet gets encapsulated into UDP for the fabric itself, it becomes a routable packet. So the destination IP of that packet will be the destination host where the destination VM sits. And the source IP will be the source IP of the source host in this environment. The packet will be forwarded to the destination, will be decapsulated and delivered to the virtual machine. So one thing which is important to note here is that for the virtual machines, all these VXLAN overlay, all this operation is completely transparent. The virtual machine thinks that is operating on a layer 2 segment. They think that they are on the same layer 2 segments, in fact. That is the power of virtualization and abstraction of NSX. So this is very good if all our workloads in the environment are virtual. What does happen if we have physical workloads? How we can solve that problem? Because at this point, if we have physical workloads, we cannot extend VXLAN to that bare metal server or to that workload that sits behind the physical switch. So we have two solutions here. One we provide as part of NSX. We have a bridging functionality in NSX where we can programmatically connect a specific logical switch or a VXLAN tunnel into a given VLAN. Right? So now if you physical workloads, let's say, are sitting on VLAN 10, and your logical workloads are sitting on VXLAN 5000, NSX, through the NSX bridging functionality, will stitch these two data paths together and will make sure that the traffic is forwarded on the appropriate VLAN. So now, this is very powerful because now you can consume not just logical virtual workloads through NSX, but you can also consume physical workloads. And this is like a very common use case if you have this multi-tier application where some of the tiers are physical, for example, database tiers, and you could not virtualize. That's a way for you to still use the NSX feature and functions to build that multi-tier application. Another way of doing this is to use third-party hardware gateway. There are several vendors that support VXLAN in hardware, and so via NSX and through these VXLAN capabilities, you could achieve the same functionality. Exactly what you do with an NSX bridge function, you can do with one of these NSX, with these third-party hardware VXLAN gateways. So what does it mean in terms of, so let's take a look at the logical view of a logical switch here. We have an applications that is built over two tiers. We have a web tier and an application tier. We have a number of workloads that are sitting on each of these logical switches. These workloads, each logical switch represents a subnet, right? And these VMs are on the same subnet. And how do we map now this logical switch into a physical environment? So you will have your compute clusters that is built on multiple hosts. You have the virtual distributed switch as the vSwitch abstraction layer for the logical network that spans across multiple hosts, right? And then you have your VNI or VXLAN ID that extend wherever it's required to go. If your virtual machine VM1 is on host 1 and virtual machine 3 is like few racks away, you'll be able to still consume and build that logical network without extending any VLAN. That VXLAN extension is completely programmatic, is completely orchestrated by NSX. And if the virtual machine moves, that green arrow, basically that green line over here, will also move along. So the logical switch will extend as far as he needs to go. We talk about VXLAN requirements. And so prior to NSX, the requirement to operate VXLAN was to configure multicast in the physical fabric. Now with the NSX, we do have 3 modes of operation. The default mode of operation is Unicast. With Unicast, there are no more requirements for multicast. NSX takes care of replicating what is called like BAM traffic, broadcast, unknown unicast, and multicast, natively at the hypervisor level. Okay, so each hypervisor will replicate packets if those specific packets needs to go to multiple destinations. We have other 2 modes of operations. One is called hybrid. With hybrid mode, what we basically do is we offload some of the replication to the switches that you have in the environment. And we implement and require only layer 2 multicast, which means the replications on the same segment in the subnet, so let's say you have multiple destinations in the same logical switch, will be done by the top of rack, layer 2 top of rack. The only requirement for the layer 2 top of rack is to have IGMP snooping and IGMP querying. No requirement for PIM in this case, right? And then we have, of course, the multicast mode. This was the mode prior to NSX. With multicast mode, we offload completely the replication of the packet into the physical fabric. But that requires both IGMP for layer 2 multicast and PIM for layer 3 routing, multicast routing. So by the way, this functionality, it's so granular that you can select the mode of operation on a per logical switch base. So now on a per logical switch, you can decide what mode of operation you want to use. Let's now go into routing here. And what I want to point out on the routing piece is basically routing. It's one of the problems, one of the challenges we are trying to solve with routing is how we can make routing simpler for this multi-tenancy routing environment. So whenever you have multi-tenancy, you may have overlapping IP addresses. You may have different routing capabilities required for each of the tenants. So the routing becomes very complex. What if you could decouple, again, the tenant and the creation of the logical router from the physical network configuration? That's what we do with NSX. We provide distributed routing at the hypervisor level. So VM to VM traffic east to west, the routing happens at the hypervisor itself. We avoid hairpinning of traffic. So if you have virtual machine to virtual machine routing that happens, let's say, on the same physical host or between 2 blades in the same blade chassis, that packet can be routed locally on the same blade chassis server or on the same host without being sent to the aggregation layer of the physical fabric or to the access layer of the physical fabric. We do support, we have full feature routing protocol capabilities, OSPF and BGP. So I do encourage you to basically follow the NSX Logical Routing Deep Dive by Max Serdica that will cover logical routing very much in detail. The logical view of a routing function. So here we remember our multi-tier applications. Now we basically add a logical router. When we create a logical router, that logical router will have 2 logical interfaces, one connected to each logical switch. Each of the logical interfaces will be the gateway for all the VMs on that logical switch. And then we have what we call an uplink interface that allows to connect a distributed logical router to the northbound workloads. In this case, this could be an edge gateway that is connected then to a physical fabric. So east to west traffic will just go through the distributed logical router, but remember, distributed logical router, it's present at every host. While northbound traffic will flow northbound. So let's take a look at some of the mapping of that logical router here. Here we have the two logical switches, the green one and the red one, and we have the controller that programs the data path on each of the hypervisor hosts. So a packet that needs to go from a virtual machine on the green switch on a virtual machine on the red switch will basically be routed at the source hypervisor and then reach the destination hypervisor. In terms of routing topologies, we have, of course, the multi-tenancy topology where we have separate set of logical routers and distributed logical routers. But the most common use case in enterprise customers is to maximize that east-to-west optimization for distributed routing. And so is to maximize the span of the distributed logical router in all the environment. So in a typical enterprise environment where you don't have multi-tenancy requirements, you will have just a single flat distributed logical router. That will be connected to an edge service gateway. So east-to-west traffic, as you can see here, can be locally routed at the distributed logical router level, while south-to-north traffic will go through the edge service gateway, which is the edge that is used for the perimeter functions that connects into the physical fabric, right? So what are the concerns here? Concern is if that edge service gateway is a virtual appliance, we may introduce choke points into the network. Even if we can do distributed logical router at line rate and we could do south to north traffic at line rate on the appliances, so we can very well do 10 gig or more. This can become a concern if I have a lot of south to north traffic. Because of that, we basically came up with a solution that allows for that edge service gateway to be scaled out. So we do support, starting from the 6.1 release, a feature called equal cost multipathing, where you can have multiple edge service perimeter gateways northbound that peer with that distributed logical router. It's very similar to ECMP that you have in physical networks. Each of these edge service gateway is fully active. So now you can, as we can support up to 8 gateways, you can scale this south to north connectivity bandwidth up to 80 gig of traffic. And so now you can optimize the traffic path, and so you have multiple active paths from your virtual into the physical environment. So before we step here, I want just to give you a quick demo of the functionality for switching and routing. So what we are going to see here is the creation is the creation of these logical switches. So first of all, we create a logical switch. And this is what you see here is the UI that we have into the NSX manager. Is the UI that we have into the NSX manager, right? So we have the networking and security tab here, where we have all the different functions. We have installation, we have creation of logical switches, and creation of edges.
I'll drive it for you.
Yeah, thanks. So while Ben is searching for the play button here, but fundamentally, as you can see here, you have multiple options. You have logical switches, you have creation of edges, firewall rules, you have creation of installation. So what we are doing is here, you're going to add a logical switch in the environment. That logical switch is very simply created by clicking plus button here, choosing the name for the logical switch. In this case, we create a switch called application tier. We click OK. Then we create another logical switch. We are creating basically a multi-tier application, which is called DB tier, right? So we have a web tier, we have an application tier, we have a database tier. It's very classical multi-tier web application database. And now that we have created these logical switches, we can add virtual machines to the logical switches. So let's select one of the logical switches, one of the segments, and from the menu, we can select specific virtual machines. So in this case, we select the web service virtual machines, and we add this to the environment. We select to which virtual NIC this virtual machine needs to attach on the hypervisor and connect into the physical. So now that we have this multi-tier app, web application database, we can go and create an edge, and that edge will provide for the routing function. So when we add an edge here, notice that we choose edge as logical distributed router. Remember, the edge is like a multifunctional component of NSX. You can instantiate it as a router. You can instantiate it as a distributed router, as a perimeter router, or as a perimeter firewall or load balancer. In this case, we choose the logical distributed routing personality of the edge. We give it a name. We click Next. And here, we have connectivity now from this logical router to each of the logical switches that we have created before. So now we have connected together layer 2 segments with the logical router, and we have built a three-tier, fully functional application. And with this, I'm going to pass the ball to Ben that will cover the rest of the presentation.
Great. Thanks, Roberto. All right. So what we are effectively going to do now, or what we've seen so far, is Roberto has shown us the different architectural components. So you saw data plane, control plane, management plane. These are the fundamental components of the NSX architecture. And everything that you've seen also with the demo before, even though this was a UI, typically this can also be driven through an API. So think of the UI almost like a front end for what actually just triggered a set of API calls on the back end. And that's effectively what we mean by this on-demand application and networking deployment. So all of these things can be just like a set of API calls, and you will see actually many partners also here at VMworld showing these capabilities, that through API calls, things can be driven in a very automated fashion. So we've seen layer 2 logical switching, we've seen distributed routing. So let's hop into some of the more services-focused aspects. So I'll be going through the distributed firewall, and the distributed firewall effectively represents the underlying engine that serves the microsegmentation use case. Microsegmentation is one use case, and some of you might have heard Pat Gelsinger earlier today in the keynote talking about this one. So what I'm focusing on is more what is the underlying engine that effectively enables this. So traditionally, firewalling has been more deployed, or in general, rich L4 through 7 network services have been deployed more in a traditional way at an aggregation layer. So you would see here in this picture, the firewalls effectively have been deployed at an aggregation layer, and it is typically the task of the network admin to make sure that the necessary VLANs have been funneled through to that services layer. There are a couple challenges. I'm not going to go into these for the time being, but what distributed firewalling means is that now this packet inspection, this traffic scrubbing capability is distributed out to the hypervisor itself. So now the hypervisor, the x86 capability inside the hypervisor, we leverage a kernel module that allows us to do traffic filtering, stateful firewalling right at the hypervisor level. So let's dive a little deeper into how this looks like. Just as a reference, the session up here is more going into the microsegmentation and a couple other use cases for SDDC, but given this is more of a deep dive on the technology front, we're actually going to hop on how this is deployed. So previously, as part of the host preparation that Roberto had covered, you saw that different types of kernel modules had been populated onto the vSphere hosts, into these vSphere clusters. And so now all these hypervisors, the assumption is that they have been prepared for NSX, so they also have the distributed firewall module. As you see, these virtual machines, independent on which L switch, on which logical switch they're residing, they now can get a firewalling capability at a VNIC level. And so now no longer firewalling is just between what you previously knew as VLANs. Now firewalling can also be done inside a layer 2 domain, inside a bridge domain, what we would refer to inside a logical switch. So I can go as granular and saying VM4 at the top here is allowed or not allowed to talk to VM5, independent if it is actually at L2 or L3. Also, this enables us to have, this technology enables us, if virtual machines were to be placed due to manual vMotion or to DRS-based vMotion, that all of the rules effectively have been moved with the virtual machines. Not only the rule set, but also the state, like the connections that are active going to this particular virtual machine would be moved onto the new host as well. So it's a fairly powerful concept because all of this is still configured through a centralized API no matter where the virtual machine actually resides. So also here, a forward reference to another session that goes way deeper on this particular topic. One example that I'd like to go through is, or one thing that I want to point out here is rules now have no longer to be based on IP addresses necessarily. You can do that. You don't have to. Rules can be based, for instance, on virtual machine names as they would appear in vCenter. Rules can also be based on logical switches. So I could say all the VMs part of the web tier should be allowed to talk to the VMs on the app tier on a particular port, on a particular TCP port. So in this particular example, you see that HTTP and HTTPS port 80 and 443 would be enabled. And this is interesting because if you had additional web VMs that need to be spun up, be it for whatever reason, for capacity purposes or for maintenance purposes, now you're no longer in the business of updating IP addresses as part of these rules. No, it's actually you have a certain group and you have a policy, and now you apply the policy onto the group. If somebody joins this group or leaves this group, everything is updated for you. So this changes the model of how security can be dealt with in very dynamic environments. So going a little deeper, I'll make the example based on a Web DMZ. So we have two web tier VMs. You would also see a load balancer that effectively sits up here. We have a logical router, and the external network would be on that side. The app tier VM is just a single VM. So microsegmentation or the distributed firewall allows you now also to segment traffic on the same L switch as I mentioned before. So typically, if traffic is coming in from the outside world, what you would want to achieve is the traffic obviously comes in, potentially hits the load balancer. But if for some reason one of these VMs was compromised, we effectively can also limit the amount of traffic or the type of traffic that is sent or is allowed between virtual machines on the same tier. So oftentimes in a web tier, these web VMs are more or less stateless. There should be no requirement that the web tier VMs can talk to each other if it is kind of a scale-out architecture. So we can leverage the distributed firewall to enforce such policies. And also notice the rule that is being created is actually fairly simple. Web VMs are not allowed to talk to each other. Furthermore, I can allow that only HTTPS traffic would be allowed into this particular tier of virtual machines. And also, I will say that other types of traffic could be blocked. And lastly, as part of me defining things based on destination, again based on a logical switch, basis, I can say, okay, the web VMs are potential sources for traffic that go to an app tier. And all of this, again, can be distilled into a template. And so you heard about vCloud Automation Center, or now called vRealize Automation. This can be distilled into effectively a template, into a blueprint, and can be deployed n times. So that is the power of automation that we can bring, and the underlying engine effectively is the distributed firewall engine. So completely stateful engine with L4, L7 capabilities. Now, having said that, we realize that a lot of customers, a lot of you are used to a certain set of vendors, and this is for security purposes. We integrate with a number of vendors, and so I'm going to make the example here based on Palo Alto Networks. So this is a solution that is available, has been announced in the February timeframe at RSA. What you would see here is that Palo Alto Networks leverages a management station called Panorama, and they leverage effectively this management station to define all the policies, all the rules, all the firewall rules, all the unified threat management rules are defined through that. And then there can be a number of clients. Those can be physical clients, physical firewalls. Those can also be virtualized firewalls. In their case, it's called VM series. So the VM series is the one that you actually see, this module, this blue module that you see sitting down here on the hypervisor. So what happens here is first, Panorama would be registering with NSX Manager, so we have that kind of linkage. That gives us information onto what kind of hosts or what vSphere clusters that we also want to deploy the VM series Panorama Unified Threat Management solution. So you effectively select, these are the hosts or these are the clusters where I'd like to place this services VM on top of. Then as part of NSX Manager, we haven't covered this in great detail, but as part of NSX Manager, there is a function called Service Composer. And the Service Composer now allows you to say, okay, all this type of traffic should be subject to advanced traffic monitoring, scrubbing, intrusion prevention, etc. So you select, okay, maybe all the traffic for a virtual machine should be subject to that, or you can make also exclusions that, for instance, certain backup traffic of a VM, if it was an inside VM backup traffic, should not be subject to that. You can get very granular there, and as part of this definition, traffic will be redirected through the advanced firewalling capability that PAN would be showing here. So the thing that you observe is all of this, again, can be automated. If rules had already been defined through the security operations team, through Panorama, effectively these rules that can be pulled in, they are still applicable, and with that, we have a nice integration of traffic that is subject to advanced firewalling through such a partner integration solution. So I want to make it clear that this is only one example of how fundamentally this flow works. But as part of NSX Service Composer, you see multiple services categories. And these services categories, they can be on the firewalling, on the intrusion prevention, on the malware detection side. It goes all the way to antivirus, agentless antivirus. So it is a very powerful policy engine that NSX Manager effectively starts to build. Great, so much for the security and for the firewalling capabilities. Now hopping briefly to other services. Other services that NSX offers are in the load balancing space, as mentioned before, typically previously deployed at an aggregation layer. Also here, like two examples based on tenant A and tenant B. Tenant A would have a logical network deployed with a so-called inline load balancing entity. Again, we leverage the NSX Edge component to do that. Or it could also be a one-armed, for the tenant B, you see a one-armed configuration where source and testnet effectively is being leveraged to assure that forward and return traffic is funneled through the NSX Edge. Here, again, L4, L7 capabilities, SSL offload capabilities. Also here, a forward reference to one of the much more deep dive sessions on load balancing as a service. Same also goes for VPN capabilities. I would categorize this fundamentally into two pieces. One piece is the site-to-site. This is, or also the remote access VPN. This is where you have your VPN client or where you have a branch and you ultimately connect through an IPsec or actually also SSL VPN tunnel to a centralized location. This is where the NSX Edge would be terminating this tunnel, and we can just have regular L3 VPN capability. The bottom part is kind of the data center to data center or a data center to hybrid cloud connectivity, where also this type of L2 VPN tunnel, we leverage SSL VPN here, this type of L2 VPN tunnel can extend not only L2, but L3, L4 through 7 services between data centers of the same organization or even into the cloud. And this is where you see with vCloud Air, formerly known as vCloud hybrid services, where we have such capabilities. Also here, we can start to leverage some of the power that x86-based networking offers. Intel and other, Intel has effectively offered as part of the Westmere CPU generation. They have AES encryption offload as part of the native instruction set, so we can leverage, or NSX actually leverages this quite significant encryption, decryption capabilities or performance levels. Also here, cross-reference to another session. So the last few minutes I want to spend effectively on some of the reference architecture work that has been going on. So lots of feedback that we've heard from last year's VMworld is, okay, so now that I understand a little more about NSX, how do I go about it? And one thing is the reference architectures actually have been published. You will see that there are different levels of collateral that is available. It starts from NSX partner white papers, which is more kind of giving the overview from a technical point of view how this works. Then NSX partner reference designs, this is where it goes way deeper already, and you can see, okay, this is how I need to build my data center. SDDC, the software-defined data center validated guides. This is on one hand, EMC has written a guide as well as VMware. We have jointly worked together on making this happen. And then probably the deepest level, it's almost like validated design guides. And I'm going to show you a little picture here. This is truly, okay, we have chosen a particular design. Why have we chosen this design? Why didn't we build another design? How does this actually work? What can I do with all this? And what is the configuration? How do I go about truly building this? So it's really explaining all the steps in the process. These are significant sized documents. I encourage you to check those out. They have been published on the VMware communities. So if you go communitiesvmware.com and you go to the NSX section, you will effectively see all of these documents published. So with that, we're effectively also making here a quick forward reference to an NSX vSphere focused session, and the lower one is an NSX multi-hypervisor focused session. So these are design sessions that go into much greater detail, explain you what is in these design guides, and you can also have some Q&A with the experts there that actually created those design guides. So as a summary and next steps, we feel that with NSX, we have a faithful reproduction of L2 through 7 services, and actually we can drive certain policy aspects all the way into the virtual machine. These services, as they are provided by NSX, are designed for scale out. As you add more compute capacity, you also add more services capacity. So all of it, even though it's a scale out approach, is driven through a centralized API or a centralized UI, which enables a great deal of automation. Then all of the NSX components have been designed with resiliency in mind, so we don't create any single point of failure in the system. And we look at NSX as a platform. I gave you little bits and pieces of what kind of integration we have with various partners. So as a last point, what's next? Well, we encourage you to check out the hands-on labs. The SEC 1403 is essentially a basic NSX introduction lab where you set things up, and then the other one is the advanced lab where you kind of do the continuation. And so I encourage you to check out these hands-on labs. They are available now here at VMworld. They will be available also post VMworld with a bit of a delay, and you can always go and check those out. From a learning standpoint, again, we encourage you to check out these resources that are listed in the center section. There is also a significant amount of work that had been done for the certification aspect. So we have VCP focused on network virtualization. As mentioned, we also just launched VCDX, so the design expert for network virtualization specifically. So if you want to go for some of these certification, everything is available to you at this point in time as well. And last but not least, deploy the technical information. How do I get about deploying NSX? How do I try NSX in my own environment? You find plenty of information there. So with that, we would like to thank you very much for your attendance. Appreciate you filling out the surveys, and we are here for more questions. Thanks.